All right, let's use a little direct substitution here. Let me go to the new page. Let's use direct substitution to find. Use direct. Oops, sorry. Direct substitution to find about f of 2. Okay. Where we have this polynomial. You guys will probably remember this pretty quick. F of x equals, let's go 2x to the 4th minus 4x cubed plus x squared plus 1. Okay, so direct substitution just says, well, plug that 2 in for who? Plug the 2 in for x, right? Plug the 2 in for x, anywhere there's an x. 2 to the 4th minus 4 times 2 cubed plus 2 squared plus 1. Where's 2 to the 4th is 16. 2 to the 3rd is 8. 2 squared 4. And so on. So we got 32 minus 32. Looks like that's gone. And we got 5 here. So it looks like f of 2 equals 5. In other words, y, remember f of x stands for y equals 5. So when x is 2, y is 5, looks like that point is on there. And here they were asking find the value of f of 2. So the value is f of 2 equals 5. And I want you to remember on that graph, if you were graphing that, you'd have the point 2, comma 5. 2, comma 5. So that's a little bit about direct substitution with some polynomials, just to kind of remind you how that works. Now you have when you're working with polynomials, you're going to have what's called end behavior. Okay, these polynomials are interesting. They always have smooth curves. They're continuous. The graphs of these things are continuous. So when you put your pencil on them, you don't lift it. You draw the whole thing continuously. Okay, and they're smooth curves. Okay, that's a little bit of the behavior. But more specifically, you got some end behavior of these things. Some end behavior. Okay, so let me write first of all your polynomial again. That's not very good. A sub n x to the n plus a. Okay, so we're right here. Now, the end behavior of a function. Like you know how x squared is a polynomial, right? It's degree 2, just the old basic parent function x squared. You know, if you're thinking about x squared, like, oh yeah, I know what that looks like. Looks just like that, right? Well, the end behavior is it goes up to the left and it goes up and to the right, okay? And you can tell a lot about a polynomial by its end behavior, and it helps you graph it, okay? Because it's not always going to be so simple as x squared, okay? And the leading coefficient as well as the degree, so the degree n in this leading term, the degree n and the leading coefficient are what determine the end behavior, okay? So let me erase this real quick. You know what? Let me go like this. Oh, how do I do that again? There we go. Okay, so the first thing you want to look at is number 1. If n is even, you have a couple of situations, okay? Like x squared. You want to think about if x squared. So if n is even, so like for instance, let's say it's f of x equals x to the 4th or x to the 6th, something like that, okay? If the leading coefficient is even, then you have 2 scenarios. Here's your first one. If a subscript n, so your leading coefficient is also positive, guess what it does? It goes up to the left, up and to the right, just like the old x squared. So I like to think about x squared when I think about this. You notice in x squared, your degree is even, and your leading coefficient, which is 1, your leading coefficient there is positive, isn't it? Okay? So think about y equals x squared. So it goes up to the left, up to left, and up to right. Okay? Now there is a formal way to say that. Okay? Is that as your x value goes to the right, okay, so as you're following this thing, as you're following this graph to the right, what does your y values do? Hey, your f of x, your y values also go to the right, don't they? And then as your x value, as you shoot left on this function, okay, as you shoot left, notice I'm following here, as you shoot left, as the x values move to the left, you notice the y values shoot up, don't they? F of x shoots up. So that's why it's up to the left, up to the right, because as your x moves right or left, you're shooting up either side, okay? So that is if your degree is even and your leading coefficient is positive, okay? Degree is even, leading coefficient positive. So now the second scenario is your degree is even again, n is even, but this time your leading coefficient is negative. So when you're thinking about this one, think about like negative x squared. That's what you want to think about, okay? Think about think about y equals negative x squared. You notice on negative x squared, notice your degree is 2 there. And you see that negative in front there, that negative 1 in front, that coefficient. Okay, so the degree is even. If the degree of any polynomial in that first term, the degree is even and the leading coefficient is negative, it's going to go down to the left and down to the right, okay? You see those dots? You see those dots between you see those dots between the arrows there? That means I don't know what this does. You know, maybe it drops down, who knows? I don't know what it does in between, but I do know I'm guaranteed to go down to the left and I'm guaranteed to go down and to the right. So as x goes to the right, f of x shoots down. Your y value shoots down. As x goes to the left, your y value shoots down. Okay, so as you go down to the left and down to the right, as you follow your x values right or left on this, okay? Now, the second scenario is, so number 2, what if your degree, your n, is odd, okay? I'm thinking of the old classic x cubed, okay? I like to think of x cubed. So if you're looking at x cubed, you know how it kind of looks like that, right? Well, in x cubed, okay, your leading coefficient is positive, okay? You're thinking about y equals x cubed. You notice your degree 3, so your degree's odd. Leading coefficient there's 1, so your leading coefficient is positive for this, okay? So that's how this is going to behave. So it's going to go down to the left and up to right. Okay. In other words, as we go to the right, or no, let's go to the left. I'm sorry. As x goes to the left, what does your y value do? See how as we're following this thing to the left, and again, I don't know what's going on in the middle here. Okay. Well, I do for x cubed, but if for any function that has a degree odd and leading coefficient is positive, as we go to the left here, we're following this thing, you notice it goes down, right? The f of x goes down. Oops, that's a negative infinity. And as we go to the right, x value has followed it to the right, our f of x value ends up going up. You can see that. It goes up there. Okay, it goes up. Down to the left, up to the right. Now again, as your n is odd, so a degree is odd for any polynomial, and this time we're going to do it with the leading coefficient being negative. Okay, the leading coefficient being negative. Think about y equals negative x cubed. Okay, so that's going to flip-flop that. And again, who knows what's going on in between there for this, but you do know it's going to go up to the left, up to the right. Up to the left, oh, I said that wrong. Up to the left and down to the right. Okay, so in other words, as x goes to the left, I notice that my y value goes up. And as x goes to the right, notice that my y value goes down. Notice that my y value goes down. Okay?